Von Neumann has said that one never understands math, you just get used to it. So that's my entire thesis on physics. So the whole discussion about, which I've been trying to propound for a long time, but I go again and again and again and try to clarify, bring more lucidity and exactness to it. So let's try to visit the scene of the action through looking at a few statements by physicists of the recent past. We have Steven Weinberg is saying he's not comfortable with the many worlds interpretation. So that's the whole thing. He's not, in other words, it's as though he's not used to it. He's not used to it. So this is the whole question of the quantum world, which the best representation is Schrodinger's. So the cat in the box, and the inside of the box is what only his equations, Schrodinger's equations, and then later on some other people modify it, but can give us any predictive ability about. And then he says, when you open the box, you find out the cat is either dead or alive, but as long as you haven't opened it, it's both. So this is what. So let's look at another testimony. What a Princeton-trained physicist, Bryce DeWitt, is saying corresponds to this problem of the positing entities of this Occam's claim of that one should limit the number of entities one posits to what we really know. So the step on this positing of extra entities is Ptolemy posing himself the question, okay, we have a certain number of countable stars in the sky, and there's about, during opposite seasons of the year, there's about equal, and therefore we can conclude we're in the center of the universe. He has the possibility before him that there's more stars beyond the visible stars, but he rejects it. If he were to posit more stars beyond the visible stars, he would be positing an extra entity, or a great number of extra entities. This is what Occam's razor tries to avoid, is positing entities we can't really see. So in the same way, the many worlds interpretation posits this cat, which is both there, alive and not alive, or something similar in the invisible world that only Schrodinger's equation and some other quantum equations can reach, but which classical equations cannot reach. And then the question is that region, so analogous to the stars beyond the ones that we can, visible stars that we can see, something that we can be comfortable with, even though we don't have any real data about it. And so Weinberg is saying he's uneasy about that. He's not happy with it. These are both physicists that have died in the last decade or so. So of a generation no longer with us. So that's one school of opinion, that it's there's some problems here, and the Einstein is on that side. And then there's this other school of opinion saying, well, it's really just like the question of the stars. We're positing an extra entity. We have no direct evidence of it, but it makes some sense. And possibly we could never get any direct evidence of it, but that's a little bit rash, because after all, there's only been 100 years we've been dealing with this problem. So taking both views, Michael Atiyah, Atiyah, Sir Michael Atiyah, who's also of a generation recently parted, um, relatively recently. He's analogized the situation to the situation with the operator called imaginary numbers, because he said when he was young, um, physicists and mathematicians were not comfortable using that kind of math, using imaginary numbers, but they've become comfortable. My observation is this is something intergenerational. So people, if they have a apprenticeship to a master who is a master of using those operators, then it becomes more natural for them in the next generation. So this, I believe, is complicated by the fact that the physicists themselves are they're in, like the rest of us, they're listening to the popular discussion all the time and influenced by it, especially when they're younger, and therefore it matters to some extent even in their later mature work what they've got into their system when they're younger. So I think that's the crux of the situation. And then one could go to the 2022 Nobel Prize and see what's happening there, where the claim is more in the direction of saying, look, we have these situations where we open the box, we take a measurement, and then the math that we have for dealing with by analogy, the stars that we can't see, or the cat that we can't see, once we close the box again, we can predict what's going to happen, at least better than we could before we took the measurement and used those mathematical methods to get a probability about it. So the thing is that this method is only probabilistic. It's not like the measurement only gives you a better chance of guessing. It doesn't give you, it's not perfect. So I think it's the simplest and most intuitive way that we can think about it as ordinary people who aren't steeped in the quantum theory from the point of view of that, doing the actual calculations, is the Monty Hall problem, because it's exactly the same information type of problem. It's you find out that switching so look at the Monty Hall problem, but you find out that switching the door gives you better odds, and the simple reason is because the first decision you took was 1 out of 3, and the second decision you take is 1 out of 2, but it's not. But it's due to the fact that there's a deliberate information reveal happens. But still, a 1 out of 2 chance, you could still be wrong. It's just you have a better chance than 1 out of 3. So it's something similar to that is happening, where they find a way to get a better chance of getting a right answer, but it's still opaque. It's still a region that we can't actually look at. It's still like talking about the remote stars that are outside our vision. And in this case, some people want to say maybe we can never see the quantum world. And then there's the extra added question of, merely because it's giving us better predictive power, does that mean that it's actually correct? So the other thing that Bryce DeWitt says is at the beginning of the Galilean period, when we got the most important notion of the modern physics, which is the mathematization of the inertial frame of reference idea, that you're on, say, a ship, and you're in the cabin where you can't see outside, and then if it's pretty still, you could be moving without knowing that you're moving, right? Inertial frame of reference, which reveals no information about your motion, but you could be moving relative to other things. you wouldn't know that you're moving. In the same way, he analogizes this many worlds interpretation to being in a situation where you're moving and you can't prove to yourself that you're moving. He analogizes that to the cat being both alive and dead. So that's like a free will issue. You're in two situations, but it hasn't been revealed at the level that the apparatus or the piece of machinery that takes the measurement at our this scale of that Newtonian physics can handle. Um, uh, it's happening then according to that, but we just don't know about it. So we just don't know that we're split in two. Just in the way that we could be in a room, or just in the way that we're standing here on the Earth, which is spinning at a very great rate, but we just physically we don't know about it. We only know about it through because we know about it from seeing, say, a picture of the Earth spinning, from having it explained to us that the Earth is turning around, or through other means, but we don't know about it directly.